Next, we discuss the relationship between sample space, events and probability. As we know that sample space consists of all the possible outcomes represented by corresponding sample points. Here, let us consider 6 sample points which represents a sample space. Now, on the basis of event statement, we can represent different events. Let us call it event A, B and C. Here, sample point S1 represent an elementary event A that is based on event statement, for example, a case of throwing a dice. The event of one.show correspond to only one sample point S1 and it is called an elementary event. Also, there is an event corresponding to large subset. For example, for event statement that is even number of dots show, then in this case this event B correspond to subset of 3 sample points that is S2, S4 and S6. Similarly, the subsets S3 and S5 map to event C that is on the basis of event statement called odd number of dots greater than 1. So the subset is of only 2 sample points S3 and S5. So here we observe a relationship between sample space and event. Here the sample space is mapped to the number of events that depend on event statement, and corresponding to these events we find the probability whose value are assigned between 0 and 1. So in short, the relationship is first sample space that is capital S is mapped to number of events using any random experiment and based on event statements, and corresponding to these events we find the probability of occurrence of that event whose values are not very unique but lie between values 0 and 1. Next, we note a point. In case of mutually exclusive events, for example, in case of tossing a coin, there is only 2 events, head A and tail B. So the probability of occurrence of head A and tail B is simply half. So we say that for mutually exclusive events, same probability may be assigned. And also for mutually exclusive cases, for sure events, that is all outcomes or A union B, probability is always unity. That is probability A union B equals to 1.